Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of the cyclicity where I have covered how we can find the unit digit or the last digit of the higher parts of a number. So if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to see how we can find the last two digits of the higher parts of a number. So let us start with today's video. The last two digits of a number is same as the remainder when the number is divided by 100. Now, sometimes in some competitive exams, we are being asked to find the last two digits of the higher parts of some numbers. For example, say if I have this number, say 137 raised to the power 125, and we need to find the last two digits of this number. The last two digits of 137 raised to the power 125 would be same as the last two digits of 37 raised to the power 125. Now, it won't be practical for us to find the last two digits by multiplying 37 125 times. So there has to be some way or some rules which will help us to find the last two digits in an efficient way. So let us see those rules first. The first rule is the simplest one, which is if the unit digit of the number is 0, then all the higher parts of that number will end in at least two zeros. For example, say if I have 10 raised to power, say 1, 2, 3, 4. Now, if I want to find the last two digits of this number, so this would be simply 0 and 0. Why? Because 10 is 1234 times, so it will contain at least two zeros. So any number whose unit digit is 0, then all its higher powers will end in at least two zeros. Let us see the second rule now. If the unit digit of the number is 5, then all the higher powers either end in 25 or end alternately in 25 and 75, depending on whether the tens digit is even or odd. For example, say 25 square will give us the last two digit as 25 because 25 square is 625. In a similar way, 25 cube will give us the last two digit as 25 times of 25, which would be 25 again. 25 raised to the power 4 will give us the last two digit as 25 again, and so on. Whereas if I take the last two digit of 35 square, so this would be 25, whereas 35 cube will give us the last two digit as 25 times of 35, which would be 75. 35 raised to the power 4 will give us the last two digit as 25. 35 raised to the power 5 will give us the last two digit as 25 times of 35, which would be 75 again, and so on. So if a number ends in 5 and the tens digit is an even number, then its higher powers will always have the last two digit as 25. Whereas if the unit digit is 5 and the tens digit is an odd number, in that case, the higher powers of all such numbers will end alternately in 25 and 75. Now, let us see the third and the fourth rule. So the third rule says the unit digit of the number ends in 1, 3, 7 or 9, then there is a cycle of at most 20 distinct remainders or some factor of 20, that is 1, 2, 4, 5 or 10, and the 20th power of all such numbers will be ending in 0, 1 always. In a similar way, if the unit digit of the number ends in 2, 4, 6 or 8, then there is a cycle of at most 20 distinct remainders or some factor of 20, that is 1, 2, 4, 5 or 10, and the 20th power will always ends in 76. Now, let us take some examples to understand this in a more clear way. Suppose if I have this number 37 raised to the power 125 and I want to find the last two digits of this number. Here I have tabulated the last two digits of the higher powers of 37. For example, 37 raised to power 1 will give us the last two digit as 37. 37 raised to power 2 will give us the last two digit as 69. 37 raised to power 3 will give us the last two digit as 53. 37 raised to power 4 will give us the last two digit as 61, and so on. So in this way, when I write 37 raised to power 20, in that case, I'll be getting the last two digit as 0, 1. So again, if I take 37 raised to power 21, so this would be 0, 1 times of 37, which will give us the last two digit as 37. And 37 raised to power 22 would be again 37 times of 37, which would be 69, and so on. So here we can see that 37 raised to some higher power will repeat after a cycle of at most 20 distinct remainders, and every 20th power of 37 would be 0, 1, after which it would be giving us the same last two digits. But if we consider this case, that is the last two digits of the higher powers of 43 raised to power 473. So here 43 raised to power 1 will give us the last two digit as 43. 43 raised to power 2 will give us the last two digit as 49. 43 raised to power 3 will give us the last two digit as 07. 43 raised to power 4 will give us the last two digit as 01. Now, since we have 01 here, so when we'll be finding the last two digit of 43 raised to power 5, this would be 01 times of 43, which would be 43, and this cycle would be repeating again and again. So here there is a cyclicity of 4, but in this case there was a cyclicity of 20. So depending on the numbers, there would be a cyclicity of at most 20 distinct remainders or some factor of 20, that is 1, 2, 4, 5 or 10. Now, instead of remembering for which number there would be a cyclicity of 1, there would be a cyclicity of 2, there would be a cyclicity of 4, and so on, what we can do is we can simply remember that if the unit digit ends in 1, 3, 7 or 9, there would be a cycle of at most 20 distinct remainders. Because if the last two digits of the higher powers of numbers follow a cyclicity of 1, 2, 4, 5 or 10, then it will also follow a cyclicity of 20. So simply by remembering this, we would be able to find the last two digits of any higher powers of any numbers ending with 1, 3, 7 or 9. For example, the last two digits of 37 raised to power 125 would be same as the last two digits of 37 raised to power 5. Why? Because it will have a cyclicity of at most 20 distinct remainders. Now, the last two digits of 37 raised to power 5 can be found out easily simply by writing it as 37 times of 37 square whole square. Now, this would be same as 37 times of 37 square will give us the last two digit as 69, and there is a square here. So this would give us the last two digit as 37 times of 69 square, which will give us the last two digit as 61, and 37 times of 61 will give us the last two digit as 57, which is same, which we can verify from this table. So we need to simply remember that if the unit digit of the number ends in 1, 3, 7 or 9, in that case, there would be a cyclicity of at most 20 distinct remainders, and every 20th power will ends in 0, 1. In a similar way, if the unit digit of the number ends in 2, 4, 6 or 8, there would be a cyclicity of 20 distinct remainders or some factor of 20, that is 1, 2, 4, 5 or 10, and the 20th power will end in 76 in this case. For example, say if I want to find the last two digits of 24 raised to power 263, we know that it would follow a cyclicity of at most 20 distinct remainders. So the last two digits of 24 raised to power 263 would be same as 24 raised to power 3. So this will give us the last two digit as 24 times of 24 square, which would be 24, and 24 square is 576. So the last two digit would be 76, and 24 times of 76 would give us the last two digit as 24. So the last two digits of 24 raised to the power 263 would be 24. Well, if you look closely here, 24 raised to the power 1 will give us the last two digits as 24. 24 square will give us the last two digits as 76. 24 cube will give us the last two digits as 24 times of 76, which would be 24 again. And 24 raised to the power 4 would be giving us the last two digits as 24 times of 24, which is 76 again, and so on. So in this case, we can see that it follows a cyclicity of 2. So 24 raised to the power 263 will give us the last two digits as 24. But every time we need to remember that the higher powers of 24 follows a cyclicity of 2. In a similar way, the higher powers of some other numbers will follow a cyclicity of 1, 4, 5, or 10. So instead of remembering which number follows which cyclicity, what we can do is we can simply remember that all such numbers will follow a cyclicity of at most 20 distinct remainders, from which we can find the last two digits of the higher powers of any such number. Now let us find the last two digits of these two numbers. The first one given here is 352 raised to the power 542. I know that the last two digits of 352 raised to the power 542 would be same as the last two digits of 52 raised to the power 542. And we know that all such numbers follows a cyclicity of 20. So the last two digits of 52 raised to the power 542 would be simply 52 raised to the power 2. Why? Because when 542 is divided by 20, the remainder is 2. So the last two digits would be simply 52 square, which is 52 times of 52, which would be 0, 4. So the last two digits of 352 raised to the power 542 would be simply 0, 4. Let us find the last two digits of this number now. So here the number is 1484 raised to the power 269, and we need to find the last two digits. So the last two digits of this number would be same as the last two digits of 84 raised to the power 269. And again, it follows a cyclicity of 20. So the last two digits would be same as 84 raised to the power 9, because 269 when divided by 20 will give us a remainder of 9. Now 84 raised to the power 9 can be written as 84 times of 84 square to the power 4. And this would be 84 times of 84 square will give us the last two digits as 56, and this is raised to the power 4. Again, this would be 84 times of 56 square raised to the power 2, which can be written as 84 times of the last two digits of 56 square, which would be 36, and there is a square, which would give us the last two digits as 84 times of the last two digits of 36 square, which would be 96. And when 84 is multiplied by 96, then the last two digits would be simply 64. So the last two digits of 1484 raised to the power 269 would be simply 64. Well, you may find this multiplication of two two-digit numbers a bit lengthy, but there is a shortcut by which we can directly multiply two two-digit numbers, which I've already covered in how to use shortcuts and tricks video, the link of which I have given above and also in the description box. So I would suggest you to watch that video to reduce the time in calculation, so that the last two digits of the higher powers of numbers can be found out in a few seconds. Now let us see this question. Find the remainder when 364 raised to the power 79 is divided by 100. So indirectly, the question is asking us to find the last two digits of 364 raised to the power 79. So the last two digits of 364 raised to the power 79 would be simply the last two digits of 64 raised to the power 79. And we know that it follows a cyclicity of at most 20. So the last two digits of 64 raised to the power 79 would be same as the last two digits of 64 raised to the power 19, because 79 when divided by 20, the remainder is 19. Now to find the last two digits of 64 raised to power 19, we can write this to be 64 times of 64 squared to the power 9. But this would be a little bit calculative and it would consume a little bit more time to find the last two digits. So let us see an alternate way by which we can find the last two digits easily in this case. I know 64 is 2 raised to power 6. So 64 raised to power 19 can be written as 2 raised to power 6 to the power 19, which would be 2 raised to power 114. And again, the last two digits of this would be same as the last two digits of 2 raised to power 14, because this will also follow a cyclicity of 20, and 114 divided by 20 will give us a remainder of 14. Now we know that 2 raised to power 14 can be written as 2 raised to power 10 times of 2 raised to power 4, and 2 raised to power 10 is 1024. So the last two digits would be 24, and the last two digits of 2 raised to power 4 would be 16. So the last two digits of 24 times of 16 would be simply 84. So the remainder when 364 raised to power 79 is divided by 100, or the last two digits of 364 raised to power 79 would be simply 84. So that's it for today's video, in which we have seen how we can find the last two digits of the higher powers of numbers. I would also suggest you to practice some more questions to find the unit digit and the last two digits to get more comfortable to the approaches that has been discussed in this and the last video. So I hope you have learned something in today's video, but if you have any confusion, you can watch the videos again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.